Okay guys, here we go. 7.3, sample means. Okay, the sampling distribution of a sample mean and the standard deviation of a sample mean. So let's take a look. Suppose that X bar, we need to make a bar in there. It's almost impossible to do that on the computer. So, there you go. The bar showed up over there, I don't know why. Is the mean of an SRS of size n drawn, I should say drawn, from a large population with mean mu and standard deviation sigma. The mean of the sampling distribution of X bar is the mean of the population. If they give you the mean of the population, that's the mean of your sampling distribution. Okay? Now the standard deviation is a little different. Okay? The standard deviation of the sampling distribution of X bar is the population standard deviation divided by the square root of n. Very important you note that little difference, okay, that happens with our sample means. And this is all true as long as the 10% condition is satisfied, which means your sample size is less than or equal to 10% of the entire population. Okay? The sample mean is an unbiased estimator of the population. Okay? The values of X bar are less spread out for larger samples, and that's what we're going to see in this section. You probably already remember that from the beads, okay, from the beads example. The larger the sample size, okay, the smaller the variability, okay, because they should approach whatever that true mean is. And this is what we hopefully learned in the beads example, okay. You should use the formula for standard deviation only when the population is at least 10 times as large. That's our 10% condition. So the whole thing is dependent on the 10% condition. You have to know that. Okay? So, first one we're going to look at, it says football players on a boat. And I wrote that note in there for myself. Okay, it's an example that I have found somewhere to try to show you. We've got two examples there. I think I'm going to do the texts for one first, and then we'll do the other one. All right? So here we go. Here we go. Sample means. Write this down somewhere in your notes. I think it's helpful. Okay? We're going to say that the mean number of texts sent by students is 30 texts, and we expect that to vary by 10 texts. Okay? This is student texts. Per school day. Now, believe it or not, this wasn't that long ago, man. It was like, I started teaching this in the fall of 2014. Okay? And back then, with the technology, texts were the thing. Now you guys probably don't even text. You do it snaps or other ways that you communicate. Okay? So we are going to say we took 100 students. Okay, that's our sample size. Now, are they all going to average 30 texts per day? No, some are going to be above that, some are going to be below that. Okay? But we'll say on average, for the 100 students, that our average is 30 texts. So if we were to, okay, if we were to say this was 30, and we were looking at all of our student texts, and we were taking all these samples. We sample 100 students, they came in here. We take another 100 students, okay? Their average was there, that's where their X bar was, okay? And you take more, and then you take this one class where nobody's paying attention, way down here, okay? But most of these that are these X bars, okay? Most of these that we take, these groups of 100 students, are going to pile up near the true mean, which they tell us is 30 texts. And if you look at the graph is kind of normalish. Okay, it's kind of normalish. This is an approximate sampling distribution. Now, we've talked about this a few times. I'm sure I have in previous videos or in person. You rarely see an actual sampling distribution, okay? Because that contains every possible combination of 100 students and what they think of, okay? So this is just like an approximate one. It's an approximate sampling distribution, okay? And all of these X bars are our sample means, okay? And that's a statistic. So let's find out what this is for the population, okay? This is for the population. Now let's find out what the mean and the standard deviation of the sampling distribution is, okay? Now the mean of the sampling distribution is the same as the mean of the population. So the mean of my sampling distribution, the mean of my X bars, we are going to say is 30. Okay? Now, my standard deviation, okay, my standard deviation of my X bars is going to be equal to, like over here, the population standard deviation divided by the square root of n. You have to know that distinction between the two. Okay? So, here was my population. That's what they tell you the population is. And then we have to do it for our samples, okay, and take our sample size, which they said was the square root of n, and our square root was 100, okay? So what are we going to find for our standard deviation? Our standard deviation is going to be 1, okay? So remember, a sampling distribution is when you sample and sample and sample and sample and sample and sample. And all of these little X bars represents samples of size 100, okay? And we're going to be investigating what happens with that in this section, okay? A bunch of little X bars, okay? So, let's move on to the football players in a boat. You probably don't have this written on there. Okay, you probably don't. It's just a note for me so I didn't forget. Sometimes I go through these and I've got my own handwritten notes like this, okay, and I've got the type notes that I give you. And I don't want to forget some of the important things that I found over the years that are in my handwritten notes. So again, another sampling distribution. Another sampling distribution for X bar, okay, a sampling distribution for X bar. So, a boat can handle 2,160 pounds, okay? 9 football players go fishing, okay? 9 football players go fishing. What is the probability that they go over the weight limit for the boat? B-O-A-T. Okay, so here's our problem. It's not complete. We need some more information. Okay? But a boat can hold 2,160 pounds. 9 football players go fishing. What's the probability that they go over the weight limit for the boat if the mean weight of a football player is 220 pounds with standard deviation equal to 30, and we assume the population is normally distributed. Okay? So you want to have that written down, because I think it's helpful. I do. I think it's helpful. Okay? So if this boat can handle 2,160 pounds, we've got to find out what the average weight of each football player could be. Like, what's the high? What are we looking at here? Okay? If they go over, okay, if they go over, we're saying that, like, X is greater than this 2,160 pounds, but because there's 9 football players, we're going to take the 2,160 pounds and divide by 9, okay? And when we do that, it's 240. So we want to know the probability that X is greater than 240, okay? So we take some samples, okay? We're going to start sampling this. Okay, I hope you've copied that. If you haven't copied it, pause the video and copy that, all right? Like, I don't have much space in it. So, here's our 240. We start sampling, okay? We start sampling. And what do we think? What do we think is going to happen? What do we think with our X bars? Okay, our X bars should pile up by our true mean. That's what should happen. Okay, that's what should happen. So let's figure out what's going to happen with our little normal model here. Okay, our little normal model. They tell me that the mean was 220. Okay, the mean was 220. That's what this should say, 220. So I put 240. Got ahead of myself a little bit. 240 is what the weight of the boat is. Okay? So 220 is where my actual mean is. Now I've got to figure out what the standard deviation is. The standard deviation was, they gave me, for the population was what, 30? Okay? But now I need the population of the sampling distribution, which means we take that, the population standard deviation, and divide by the square root of n. Well, they told me that it was 9, we're putting 9 people in this boat, okay? So that's going to be the square root of 9. So it's going to be 30 divided by the square root of 9, the square root of 9 is 3, so 30 divided by 3 is 10. Okay, so I cut off the tails and split the uprights. Here's 230, here's 240. I should already have an idea. You guys remember, if you can remember back to chapter 2, you should already have an idea of what's happening here. They want the probability that we're out here, that the weight of the football players that exceed the boat, they're going to sink like stones. The probability that X is greater than 240, well, let's do it. Let's get a Z-score. Let's do it. Z-score, 240 minus the mean, 220, divided by the standard deviation. The standard deviation that we use, again, is the population standard deviation. The population, what they tell you for the entire population, divided by the square root of n. Okay? And our sample size here was 9. Okay, so this is going to be divided by 10. So it looks like I get 20 divided by 2. I get a z-score of 2. Okay, a z-score of 2. So now we go to our old friend, norm CDF, 2 to 999, and I'm going to get approximately point, what? I'm going to have that down a little bit. It says 0.025. I don't know if that's accurate. I want to make sure that it's right. So I go to second dister, vars 2 to 999. 0.0227, so about approximately 0.025. Okay, and we should know that, right, from our normal model knowledge. Okay, mean 68, 95, right? So there's 95. That means there's 5% of the two tails. We want just that tail, so it's approximately 0.025. Okay? I hope that makes sense. I do. I really do. All right? So there are a couple problems here that I want you guys to do. So let me slide this up. Let me erase this first. Let me erase. Right? We're going to slide this little guy up, and you guys are going to try the problems about movie-going students. Okay? Movie-going students. Suppose the number of movies viewed in the last year by high school students has an average. I bet you it's not now. I bet you it's not now with COVID. Okay? Or maybe it's more, because people are staying home and watching movies. But it says movie-going, so I would think that means going to the movies. And I think that number's way down. Okay, so the mean is 19.3 with a standard deviation of 15.8. That is for the population. Okay. Suppose we take an SRS of 100 high school students and calculate the mean number of movies viewed by the members of the sample. What's the mean? What's the standard deviation? And check the 10% condition. So I want you guys to do that. I want you to do that. All right, let's take a look. Let's see what you got. What's the mean of the sampling distribution? The mean of the sampling distribution is the same as the mean of the population. Okay, I hope you remember that. I hope you remember that. So the mean of the sampling distribution is the same as the mean of the population, which is 19.3. Okay? And then we got to find the standard deviation. The standard deviation is equal to, of x bar, is equal to the population standard deviation divided by the square root of n. So in this case, we are going to take 15.8 divided by, this is my sigma for x bar, divided by the square root of the sample size. What's the sample size? The sample size is 100. The square root of 100 is 10. 15.8 divided by 10 is 1.58. So there's my mean. There's my standard deviation of the sampling distribution. Now we want to check to see whether the 10% condition is satisfied. Well, what's my sample size? So for this, I need to make sure that n is less than or equal to 10% of the population. What's my population here? 100 high school students, or high school students, I should say. The sample is 100. So my population is high school students. So I would say 100 is less than or equal to 10% of all high school students. Okay? That's an easy one. Okay? There's no question you take a sample of 100 high school students. If you're trying to make a generalization based on all high school students, you take a sample of 100 high school students, we know that's less than or equal to 10% of all high school students. That's almost here and where, almost, right? So all high school students, probably millions, right? Probably millions of high school students, all right? So we would say that 100 is less than or equal to 10% of all high school students. So we've done that. A, B, we've answered all of our cards. All right? All right, let's see what's next. Sampling for a normal population. Okay, we already talked about that. We've already done that. So let's go to this next problem. Okay, let me get rid of this. Let me get rid of this. And I think they have you do this problem. Okay? So here you go. At the Peanutty Peanut Company, isn't that clever? Dry roasted shelled peanuts are placed in jars by a machine. The distribution of weights in the bottles is approximately normal. We know that's a really important statement. We know it is. With a mean of 16.1, mean 16.1 and standard deviation of 0.15. That is of the population. of the entire population.